Welcome to another episode of the Sunday Spark, where we talk to interesting people about what they are doing with their lives, what they've done with their careers, and what interesting insights we can get from that. We had a first episode 2 weeks ago where we talked to Michael Kaufman, and now I guess we are still kind of staying in similar sciences, sort of like biology, chemistry, I think. And we're talking to Meghann Ribbens. Meghann, why don't you start and tell us a little bit about sort of your career right now, and we'll go into objectivism a bit later. But right now, just your.
Sure. Yeah, thank you, Daniel. I think some of your viewers probably know me already, but just briefly, I have a bachelor's in biochemistry from UCLA, a PhD in molecular biology from USC. I do not speak for either of my alma mater, in case they were worried. I have since had over a decade-long career as a molecular biologist, mostly working in biotech and more recently in pharma. So my last project was in gene therapy, right? The idea is that people born with a genetic disease, sometimes all they need is a little piece of extra DNA in the right place. Now, figuring out what that little piece of DNA needs to be and how to get it to the right place is a job of work. It takes years of research and even more years of process optimization, and that's where I was working. Um, I'm immensely proud of the work I've done. I've got at least one patent. I don't know where the other applications are in the process, but at least one granted US patent. Um, I've worked with organisms that have gone to space. I've gone down a mile underground to look for new species. And like I said, I've at least tried to help really sick kids flourish. That being said, ah, I have seen some real problems in the field of biology. Um, Problems that I didn't think I could fix from within. Um, and I have also had a beautiful daughter. She is now 9. And throughout her life, we've done experiments together. And if you look at my YouTube channel, MA Ribbens, Ribbens with an E at the, before the N, we've long been doing experiments together. And both of those things made me really want to transition to teaching science the way I think it hasn't been taught and needs to be taught. I go into a lot of detail about how the epistemological problems I've seen in my field have led to really devastating consequences. Um, Not just for the people working on it, but the patients and the people supporting that work, the investors. Um, Now, I don't want to get too grim, so I will say that what my daughter and I do is so fun, and I want everyone to join us, particularly young ones, even if they have no intention of being a scientist. This will make you good at being really observant and a really good problem solver, whatever your problems are in life. Um, I will also say that I'm really encouraging adults who remember nothing from their science class except boredom to give it another chance because you will not be bored. I can guarantee very little in this life, but I can guarantee you will not be bored. Does that thoroughly answer your question?
Yeah, I think as somebody who almost got held back in high school because of biology, I think I'm one of the people who would definitely sort of might find something new by looking into your things. I'm wondering where we should go. There's a few things. Maybe before we go a bit further, you can tell us a little bit about your relationship to objectivism.
Sure. I I don't know that would be fair to call me an objectivist. I certainly try to behave or espouse ideas that are consonant with objectivism. I've taken courses at, and this will date me, the former Objectivist Academic Center. Um, I've also taken courses that I found really valuable in my career, um, through the Ayn Rand University. Again, like, I am not a philosopher. I am a scientist and now trying to become an educator. So I think it's worth putting in that proviso. Um, so to answer your question about, I mean, your question probably packs in what attracted me to the philosophy. And to be honest, um, it's funny because of all the classes I took in college, and I started college when I was 16, the one that probably changed my life the most was Econ 101. Not because I want to be an economist. I knew well before then that that was not what I was going to do, but just because it changed kind of how I thought about human relationships in society. Now, am I interested in politics? Not even a little bit. Um, I'm really interested in the aesthetics and the epistemology, and that probably comes through. Those have been really, really helpful to me in ways that you'll see forthcoming.
Yeah, and that's well, one, I think it's good to point out that I don't think calling yourself an objectivism automatically supposes that you are the sort of the philosopher grade level. I think it's sort of like general accepting of Ayn Rand's ideas. But the reason why I want to connect it a little bit is, Ayn Rand has, of course, the virtue of productivity. And for me, it's always interesting to see how productivity looks different in pretty much every field, or how exactly it fulfills a specific person, right? Because I mean, you mentioned economy and politics, and I'm full on into those things. And actually, it's the
Yeah,
science.
no shade being thrown
Yeah, yeah,
here. Like, I think it's great that you do that. I do not understand why everyone does not want to be a molecular biologist. I am so grateful that there are people who love doing other things.
yeah, and so like you mentioned, you had a patent, for example, and that's like sort of my question. Like, where do you see sort of, after a long day in a lab, I guess, how do you feel like, okay, today was a good day because, I did this? Or how do you feel that sort of sense of accomplishment? How does that only happen? It cannot only happen once you get the patent, right? Because like if you only have one, it's there will be a lot of sad days, but there has to be something like every day where you feel like, wow, this is fulfilling me.
Yeah, and it's funny you say that because yeah, if you're just holding out for the big discoveries, you're gonna experience burnout before you even finish graduate school in the sciences. And I would say it perhaps particularly in biology, you're asking very specifically, nature, do you work in this very specific way? Usually the answer is no. So you're getting a lot of no's. Um, so part of what kind of keeps you motivated is having a lot of projects going on at once because most of the time in science you're troubleshooting. So at any one time, if you've got 5 projects going on simultaneously, maybe one of them you're not in troubleshooting mode, you're actually in discovery mode. Um, so and it depends on if you're doing research or process optimization. But for me, um, multitasking is really, really helpful. It's not for everyone, but it's definitely for me. Um, I will have like my to-do list, and if I always calculate my to-do list in lab minutes and not in people minutes. So like double the amount of time I think it's going to take. That's probably how long it's going to take. So if I get through half of my to-do list in a day, that's pretty satisfying. But really, the satisfaction comes from just getting another answer, right? Good, bad, or indifferent. Even if nature, do you work in this very specific way? And the answer is no. I'm a little closer to understanding a deep natural phenomenon. I'm a little closer to leveraging that to make sick kids a little closer to reaching their full potential. that's really how I think of it. And that brings me so much satisfaction. I don't remember the last time I played a video game because what I do is so much fun.
We have super chats from Jonathan, thank you so much. Super chat from Bonnie, thank you so much. Super chat from Mark, thank you so much. And a super chat from Apollos, thank you all so much. And if anybody has questions for Meghann, you can ask in the chat. And it's actually interesting that you said that, yeah, basically, even sort of realizing, nature doesn't work in this way is still a sense of accomplishment, because that actually connects to something I experience now, again, going to my, when it comes to investing. And it's every time I lose money, I'm like, okay, that's actually good stuff, because now I know this is not the way to go. So it's interesting that that still does connect. Now, there's a few things you said earlier that I wanted to go into, but there was an interesting question I had 2 weeks ago for Michael, which had an interesting discussion. And sort of, even when you have sort of like your field as the molecular biologist, there's of course different things. And I think you've also worked in different things. I believe you worked in academia, you worked in a startup, and you worked in like a sort of like a big biotech. And when did you have a realization where it was like, okay, this is the one specific one I want, and in those other ones there was something I really disliked? Or and
Um,
also, how was it different? Like, was it even different to work for these different things?
yeah, so um, those are two really good questions. I mean, I've loved every single scientific question I've ever investigated. I think it's a lot like your children, right? They're all different. Um, I mean, I have only one human child. I have a lot of scientific project babies. And you love them all for all the reasons they're different. Um, so in terms of that, there was never like I'm gonna do microbiology and nothing else, or gene therapy and nothing else. It's not like that. And maybe that's just because as a molecular biologist, I'm always looking at the fundamentals, right? The smallest elements that make it all go. Um, in terms of, I guess I would say the culture of academia versus startup versus big pharma. Um, I would say the thing that really struck me was the epistemology in a really interesting way. And I don't want to say, this is anecdotal, so please take this for what it's worth. And I don't want to say this is universal. What I noticed with academia was that a lot of times there was observation with really no interest in what those how those observations might be leveraged. And when I say no interest, that's being a little too charitable. I had a professor I really liked come up to me right after my dissertation defense and complain because my defense had the word application in the title. And he went on to say, we kind of put those words in when we're applying for grants, but and I'm hesitant to paraphrasing too much, but essentially what I was told, and not just by him, was that anything that might improve the human condition is somehow less sciencey. It's very different in industry, and I haven't noticed too much of a difference between startup and big pharma in this respect, that they tend to disregard observation altogether. So an example is, and this is at like a multi-billion dollar cap pharma company I was working at. They were trying to figure out how to make a more enriched product. Now they had at this point made dozens and dozens of batches, some of which were more enriched and some were less enriched. So they said, okay, we
Just
think it
quickly
has to
for
do
me,
with
what does enriched mean? Like potent, like better, or
um I'm 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 being intentionally vague,
okay?
right? Just imagine like if you had a vat where you were brewing your gene therapy or whatever. Um you'd want it to brew a denser batch, right? Because then purification is easier and you get more bang for your buck, right? Like if
So
you,
more
it's
efficient.
like, right. So if you were brewing beer and you wanted it to be more alcoholic, right? Like a higher alcoholic percentage would get you there faster. Um, so not that that's what I was doing, to be clear. So, all right. So they were trying to figure out how to, like, what it took, like what it took to make a more enriched product. So rather than looking at every single metric they had for all the batches where they'd made a more enriched product by accident and maybe try to figure out how to do it on purpose, right? Like all these data rich observations. They said, no, observations don't matter. We think we know what's going on. We're just going to change the amino acid sequence and see if that works. Sure didn't, right? um, so it's an example of, and this is astonishingly common, at least in my experience, where you've got academics who think observation is all there is, and to hell with the human condition, or even useful observations, and you've got industry which is saying, no, we can just skip observations, doesn't matter, not important. We know what's going on, so we'll just tweak it the way we think we know what's going on. Again, I don't think that's universal, but I was staggered at how common it was. And when I saw the particular industry presentation I was talking about, I happened to be in the room with like the number two person at this huge company. I looked over at him and I'm like, are you seeing what I'm seeing? Because this is not science. And that seemed perfectly fine to everyone who wasn't me. Um, and that was a really instructive moment for me. That was a moment where I said, there's something really off with the way science is taught and thought about if this isn't raising huge alarm bells. Um, so wow, I forgot the question. The
No,
question.
no, that's good. We're going where I want. It's interesting to see that the big pharma has a similar methodology that I do. That's when I have a problem, I just change parameters and see what it does with the result, and then based on that, I actually learn. But that's interesting to see. But we have also a super chat from Roland. Thank you so much. Who says, question to Meghann: can you elaborate on the epistemological issue you see in biology? And I think that's where we are pretty much going. So
Yeah,
yeah.
yeah. Either it's observation without any attempt at looking for correlation, and when you see correlation, hypothesizing a causal relationship and testing for that, or it's hypothesizing and testing without observation and any correlation. Um, there, it's really, in my experience, it's been really, really hard to find any kind of organization that marries the two. In fact, oftentimes when I talk about this with colleagues, they look at me like I'm being pedantic. Um, Now, maybe I'm being a little unfair to them. Maybe I've misread them, but that's, again, something I found really alarming.
Yeah, it's kind of interesting. I mean, this straight up goes to the theory practice dichotomy, which is interesting to see how much it materializes in pretty much every field for that matter. Um, so we have a few more questions that I wanna that we have from people, but since we are still on this topic, maybe you can expand a little bit on sort of how what you talked about earlier, how sort of you think specifically biology or even more generally science think should be thought to basically integrate sort of those two things.
Sure. And I mentioned on my channel an instance where I really put this into practice and discovered something at one of the companies I worked with that would have saved the well, I'm not sure how much more effective the drug would have been, but it wasn't. I knew before they went into phase 3 trials that the way they were dosing was not going to be effective, and the FDA eventually agreed. Um, and would have saved the company millions in terms of production. So I have some good on the ground evidence that the way I approach science works and can help people. So what I've done is try to make that a course that can introduce kids like my daughter, and adults who were bored in college in science class, um, how to how to what this looks like, and maybe give them some ideas for how to put it into practice in their own lives. As you were saying, when you run into a problem, instead of maybe just trying to change parameters, maybe look for a correlation between the issue you're facing and some of the other things you're already doing. So what we do is we go through a very select history of biology. It's not a history course, and it's not a traditional biology course in the sense that if your biology course started with a picture of the cell, right? You'll be asking yourself, where did that come from? You know what I mean? And it was not that long ago that I had no idea who discovered the mitochondria, right? Like, couldn't tell you how they did it, no idea. How to use that information in my own work and life, I got nothing. You know what I mean? Um, so we're gonna meet some genuine biology heroes, starting with Aristotle. Um, and we're gonna go through what it took to get from a state of knowledge, um, where we really weren't even aware of most of the living things around us, to where we are today, right? Where I can tell you what the sequence that's gone wrong in a kid who has cystic fibrosis or phenylketonuria. I can tell you what the sequence is, probably how they got it, and how to fix it, right? Like that's a huge, pardon the pun, evolution. And it didn't start by making guesses and just trying things out. And it didn't stop with observation. You start with Aristotle, and Harvey and Vesalius, really looking and being very careful, not just observing, but like carefully noting quantitative parameters about what they were observing. And then you get people like Linnaeus who say, notice some similarities here. I want to start grouping things together. And then you get people like Reddy who are like, I think I can prove that spontaneous generation is not a thing. Like life comes from other life. Like that was a huge discovery. It was like one of the first instances of a controlled experiment. And wow, how that has helped us. I'm going on and on. I can't stop. But I would say that in addition to this very select um, introduction to the heroes of biology, we're, I hate to use the word hands-on or project-based because let's be honest, I've looked at dozens of like project-based science or hands-on science, and it mostly just involves making like marshmallow and toothpick models of molecules as if a kid has any idea what a molecule is or has ever heard of Mendeleev, for example. No, we do real science. We build real inventions. So we build lenses to see how they bend light for microscopy. We make herbaria, right? So we make books of living plants the way Mary Curie did when she was a girl. In fact, I'm ready to do my setup now. At least I hope so. Um, I'm going to show the audience. Yeah, I put my money where my mouth is. So when I say that we do things, we do real science. We're going to do it right now. So let's see. Oh, that's not the one I wanted. This is the one I wanted. So I've got my phone facing my webcam. It's a little weird. Um, but in front of it, I don't know if you can see, I've got my oh whoops, I gotta flip it around, don't I? That would help. There we go. Okay, see my webcam. And in front of it is this adorable little Leeuwenhoek microscope that I made. And I'm going to put it in front of the camera. Okay. And I'm going to turn this off real quick because I've got way too much to juggle already. I've got my sample of um, moss, which you got from your herbarium sample or your herbaria. And as you can see, it's a little blurry. Shine some light, and that'll make it a little bit better. So if you can see, there's the
Yeah, now
moss.
it's good.
Beautiful. Yeah. And the tacky, oh, gorgeous. Um, so what you're gonna do is use this microscope to look at your herbarium sample, and you'll see that moss, for example, has no roots, and it doesn't even have a genuine seed. That's gonna help you in um, sort of making correlations with your herbarium samples. Now I'm in the other camera, but I'm cool with it. Um, so yeah, you're gonna learn how to make your own Leeuwenhoek microscope, and you're gonna see bacteria from the microscope that you made, and make your own observations of um, living organisms with the equipment that you invented. So yeah, thanks for letting me show that. I'm really ridiculously proud of it. It's like one of the many things that nobody asked for that I'm ridiculously proud of anyway. So yeah.
No, I mean, when it comes to biology, and I've already said I was almost held back because of it. But actually, when we had the practical things where we actually had the microscopes, that was like the one of the more interesting, well, the only interesting. I used to sleep during those lessons normally, but that was like the when I was actually awake. And yeah, I want to go a little bit more into what we're talking about, and something that more recently or a few years ago got me a bit more interested in biology is specifically, I think it was a 2022 Ocon a lecture by James Lennox where he talked about Charles Darwin. And what was interesting about it is that it was sort of like what you've said. It wasn't the way, and I recommend people checking it out. It's on YouTube. It wasn't like Charles Darwin had like some theory that he came up with in London and went to sort of like even verify it. It was pretty much every day of idea, try, idea, try, idea, try. Like it was like filling each other. It wasn't really sort of like only thinking or only like working in a field. It had to be both. It sort of was like a daily change, basically integrating both of them. And with that, actually, we have an interesting question from Peter, because you also mentioned Aristotle earlier. So thank you for your super chat, Peter. He says, "Who is your favorite biologist you cover in the series on your YouTube channel, and why?"
Um, Again, that kind of feels like picking favorite children, which I love them all. I love them differently, but I love them all completely. Um, that being said, I have to say that I directly owe my livelihood to Charles Darwin because I have actually directed evolution. Um, Thank you for asking this, Peter, because it gives me a chance to just humble brag, minus the humble. At one point I was working. So a few years ago, you may have heard of NASA. There was like these news articles about NASA finding bacteria on the outside of the space station. They didn't find it; they put it there, and the reason was that they have these special facilities, these clean rooms where they build their spacecraft, the spacecraft assembly facilities, cleverly named. It's where I've actually seen the Spirit and Opportunity rovers being assembled there, which again will date me. Um, so they're clean rooms because obviously you don't want to send a probe to Mars looking for Martian life, say, aha, we found life. And it turns out it was just something that hitchhiked from Earth, which, as we know, can happen, as for example, tardigrades on the moon. Um, so they're very careful about sterilizing these facilities, and they'll sample it every time they sterilize and keep those samples. I think they have decades worth of samples, and there are just some organisms they cannot get rid of, no matter what they do. Gamma ray, UV ray, um, ethanol, bleach, you name it, they've tried it, can't get rid of this stuff. So they're like, well, why don't we send it to space? And they did. They had these metal coupons with these bacteria on it, and they were in different conditions. And one of them was essentially in the vacuum of space, orbiting the Earth every 90 minutes. So full sunlight and then full darkness and full, and of course, significant galactic cosmic radiation the whole time. And after, a year and a half of this, they could still germinate them. Not on the outside of the International Station when they got them back to Earth. Nevertheless, these organisms are extraordinary. It was my job to figure out how they did what they did. To do that, I directed their evolution so that they could propagate, not just survive, but propagate in a certain kind of radiation that should have been millions of times more than germicidal. So here they are just happily dividing in something that should have killed them a million times over. And I was able to do that because I directed their evolution. I would, put them in just enough to kill most of them, but not all of them, and the rest would propagate. And then I'd give them, like a lunch break and a nap. So they could kind of rest and recover, and do it all over again, until they were, yeah, just happily growing in ridiculously lethal amounts of radiation. So that is entirely thanks to Darwin. That idea of directed evolution is all thanks to him. So that's my very long-winded way of saying that of all the people I have to thank in history, Darwin is probably at the top of that list.
So, for me, we have in economy Adam Smith's invisible hand, and in biology we have the invisible evolutionary hand of Meghann Ribbens.
But not so invisible.
Very visible. We have a super chat from Jonathan. Thank you so much. And we actually also have a question from Apollo Zeus, who also super chatted. Thank you so much. He asked, "Can you explain the significance of mechanotransduction in the context of molecular biology?"
Um, Not really. That's not something I really worked with directly. So I'll tell you what little I do know.
Well,
And honestly, Apollo,
I know, of course, but for people in the chat, can you tell what mechanotransduction means?
sure. So I will say, and this again will underscore my love of biology. Um, when you think about how organisms sense the world around them, and they have, like, every organism has to do that, right? They need to know what's food and what waste at the very least. Now there are lots of ways of sensing that and trying to get more food and get less waste. Um, Perhaps the most amazing example of that is the human brain. We tend to think of the human brain as only communicating on the electrical level. It's not like that. It's communicating simultaneously on the electrical, the chemical, and even the physical. It's how you know that you're being touched, right? Um, so mechanosensing, I'm even butchering the term, is that being able to, sorry, the mechanotransduction is essentially communicating on the physical level. So I'm trying to think if there were any organisms I ever worked with, because I've worked with quite a few, particularly microbially, where that was something I was really investigating. And to be honest, I was mostly working on the chemical level, and sometimes on the electrical level. For example, my doctorate dissertation was on microbial fuel cells, so microbes actually um, sending electrons from one to another towards an electrode. Um, so yeah, I'm really sorry, Apollo Zeus. I don't have more to tell you on that. But it's all so amazing.
We have a super chat from Robert. Thank you so much. He says Darwin wins for making clear in one of the greatest examples in history that quote only God can explain this and quote is never the answer, even though that wasn't his intention. See you tonight on 5 minutes because I saw that Meghann is also on Robert's channel tonight, so you can
Yeah,
also
they're
check that
very
out.
kind to have me as well. Yeah, thank you so much. And please, 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 if you haven't read The Origin of Species, read it. Um, it's such a tour de force. It just makes you fall in love with Darwin even more, if that's possible, right? Because he involves so many people. I mean, his curiosity about living things was voracious. The number of pigeon breeders and livestock owners and um um you know botanists, just like he wanted to see in every respect how living things do what they do. Um, the places he traveled, the fossils he discovered, the creatures he observed and killed and ate and saved the corpses of. And I mean, wow, if ever there was a person in love with what he did, he was it. And he was so honest about, what was clear to him, what was uncertain. Um, yeah, and and what connections he made between all of his observations and the observations of his colleagues, it's magical.
We have a super chat from Enric. Thank you so much. He asks, how likely and what type of life do you think could be found in our solar system?
Oh, I'm so glad you asked. I actually spoke to NASA about that. Um, there's not a great answer to that because we don't actually know how life got started on this planet. We're pretty certain that however many times life um, independently emerged, we are all descended from one instance of that. The similarities in terms of DNA as the permanent information molecule, as RNA as the transient message molecule, and molecular machinery. Proteins is a lot more of that molecular machinery. It's hard to avoid the conclusion that we all emerge from that one instance of life. Um, and yet we don't know really how that happened. There's this experiment from decades ago called the Miller-Urey experiment, where this grad student, and it's what he's most famous for, and he's kind of irritated by that, I guess. He's most famous for what he did in grad school. Um, he uh, he put in a flask um, kind of what he thought the early Earth ocean and atmosphere looked like, and put a little spark in it to give it a little electricity. And he was able to spontaneously generate um, some amino acids and nucleic acids, really the building blocks of proteins and DNA and RNA. Um, and to be frank, we haven't gotten a lot further. It's not like we've put together the right mixture in a test tube and out something crawls after a while. Like nothing like that has happened. And there's still a lot of competing theories of even did it evolve in the deep ocean? Did it evolve on the shores of something like Hawaii? I mean, not actually Hawaii, but something like that. People still argue about that. So, given that open question and a lot more, how would it have come about on a place like Mars, which around the same time as Earth's life was evolving almost 4 billion years ago? Um, Mars seems to be fairly Earth-like. Did life evolve there? No idea. Would it have looked similar? Again, no idea. Um, which is, so Enric, your question is a really good one too, which I don't think anyone has a really good answer. Um, I will say that um, I am very eager to try to find life elsewhere in the solar system or elsewhere in the universe because there's a lot of open questions about ourselves that I think sorry, I think it would be difficult to answer without more than an N of one, right? We have one instance of life evolving. That's us. Um, so why, for example, if you think of the tree of life very simplified, right? You've got bacteria, you've got archaea, which on the physical level look a lot like bacteria, and you've got eukarya, which includes us and yeast and plants, right? So why does bacteria cause a lot of human disease and archaea almost never? When archaea is more closely related to us than bacteria, we don't know. We have only, I always get them mixed up. I think it's only right-handed conformation amino acids making up almost all of the proteins on Earth. Not all, but most. Why? Is there something energetically better about that versus left hand? We don't know. Um, and again, I think all of these are questions that are pretty difficult to answer unless we find another kind of life that evolves independently, or not just evolved, but emerged independently. Wow. Again, you guys are just getting me going. You ask a question, I just can't stop myself.
No, I think that's good. It came out really well. Now, with that, I think mostly what I wanted to ask you I've covered, but I'll give people in the chat a little bit longer if they want to ask anything. But Megan, anything you wanted to bring up that I didn't, that you would like to mention?
Again, I feel if I get myself going, I won't be able to stop. And Daniel, you probably have like, I don't know, something else to do today. Um, but I do want to shamelessly plug our inductive history of biology course. You can find it at patreon.com/Dr. Mommy. Throw us a few bucks a month to kind of just support us coming up with all these experiments. You can also check us out on YouTube. Please subscribe and share. Subscribe because I'm trying to make this my side hustle and monetize. Share, with your friends, your enemies, particularly if they have a kid or have seen a kid or maybe know what, a human child kind of looks like. Um, I, to help make the field of science better, progress faster, and make epistemology culture wide, make us better at noticing the glorious world around us and solve our own problems. Um, there's something else I was gonna say and it's completely escaped me. But yeah, come visit us. Please, I've got all these great materials. I want you to play with them. So, there are a few bucks on PayPal and you get to discover the world as you've never known it before.
No, just quickly, Bonnie in the chat is asking when did Meghann discover Ayn Rand? Was she scientist first? I think we talked a little bit about it earlier, but I'm not sure if you mentioned which came first.
Oh yeah, sure. So I think I was in graduate school. Yeah, so I think at the time, because I'd already taken Econ 101, so all of a sudden I was a libertarian. But I was in this like they really liked how I taught. My first couple of semesters I was a teaching assistant. They really liked how I taught, so they invited me to this program to um give more advanced training to teachers, like teaching assistants to be really good teachers. And I met a friend there. Turned out he was leading the objectivist club on campus, and I I think there's probably a really embarrassing recording of me at this event with Euron Brook, and I think Fleming Rose. It was wow. I am dating myself, and I'm trying not to. In any case, he introduced me to Ayn Rand. So I would have been about 20. I was a biologist forever. And I was 12. I think I was about 12 when I became a microbiologist. I so it was the first time I saw pond water under a microscope. And I mentioned this in my channel. I don't think I had the word entropy at that point, but I had the concept of like, there's this natural force where things go to a state of like a few well-ordered um things to a whole bunch of small chaotic things. So to see all of these beautifully well-ordered structures moving about in all of these complicated ways, these impossibly tiny living things, um, when they should just be a bunch of sludge in a little drop of pond water. It was it was really a revelation. I don't know what other word to put to it. That was the moment I knew this is this is me. This is what I'm gonna do. I'm gonna spend the rest of my life figuring out how this goes. Um, so yeah, I guess scientists first, um, objectivists a little later.
We have a super chat from, I believe that's Pooja. Thank you so much. And with that, I think we covered a decent ground today. People now know you a bit more and the amazing stuff you have done and you are up to. Uh, I think you've already mentioned where people can find you, and we'll put that in the description. But any
Thank
any
you.
last thoughts?
I thank you for letting me share my love of the natural world and my love of my daughter. I can't shut up about either of them, obviously. Um, so yeah, thank you so much.
And of course, we'll be back next week with another episode of the Sunday Spark. We already have somebody scheduled, so hopefully it will be scheduled. You'll be able to find out who it is in the upcoming days. Bonnie is asking, will you be at the Irreplaceable Spark conference?
Um, Not this time around. But maybe we can convince Daniel and Radley to invite me for the next one.
Well, hopefully we'll be able to do so with that. And people can, of course, check out the Irreplaceable Spark Conference on objectivism.co.uk and find out more. If the more people sign up, the more people, speakers, great speakers like Meghann, we can invite. So there's your incentive, I think is the word we use in economy. With that, thank you, Meghann,
Okay.
for joining me today. Thank you, everybody, for watching. We'll be back next week with the Sunday Spark, and of course, tomorrow with the Daily Objective and the reality show. Until then, bye bye.
Thanks, everyone.